In this video, we're going to be going over how the reactions of cellular respiration release chemical energy. The 6 main topics we're going to be going over today are glycolysis, anaerobic reactions, aerobic reactions, the citric acid cycle, and electron transport chain. For the following slides, I will be just reading out the major key points because they are rather informational and I do have limited time on the voiceover. For this slide, both aerobic and anaerobic pathways begin with glycolysis. Glycolysis is the breaking down of glucose. Glycolysis takes place in the cytosol and it does not require oxygen. It's considered the anaerobic phase of cellular respiration. This slide is going to be the breakdown of glycolysis. So first, 2 phosphate groups are added to a glucose molecule, one at each end, in a step called phosphorylation. It requires 2 ATPs, which then are used to quote-unquote prime the glucose that is activated first, some of the energy-releasing reactions that will happen later on. Then it's just going to go on and further tell you the steps of it. Some reactions of glycolysis do release hydrogen atoms. The electrons of the hydrogen atoms contain much of the energy from the chemical bonds of the original glucose molecule. In order to keep this slide is going to be going over anaerobic reactions. For aerobic reactions, oxygen has to be present in order for the chain to continue processing electrons and so on and so forth. However, for anaerobic reactions, the electron transport chain has no oxygen. This slide is going to be a continuation of anaerobic reactions from the previous slide. The buildup of the lactic acid will eventually inhibit glycolysis and ATP production does decline. The lactic acid will diffuse into the blood and later return oxygen to normal. Continuing from the previous slide's text, pyruvic acid produced through glycolysis can continue through the pathways as if oxygen is present. From each pyruvic acid molecule, enzymes within the mitochondria remove 2 hydrogen atoms, a carbon atom, and 2 oxygen atoms. Lastly, the acetic acid combines with the molecule, which then carries it into the citric acid cycle. This slide is going to be going over the citric acid cycle. It begins when a 2-carbon molecule combines with a 4-carbon molecule to create the 6-carbon citric acid molecule. It is then able to be reused and combined within the cycle, and it will repeat as long as the mitochondrion receives oxygen and pyruvic acid. For this slide, we're going to be going over the electron transport chain. The hydrogen and high-energy electron carriers generated by glycolysis in the citric acid cycle hold most of the energy contained in the original glucose molecule. An electron passed along the electron transport chain gradually does lose energy. That energy is then transferred into ATP synthesized using enzyme complex. This slide is just going to be a continuation of the electron transport chain. The final enzyme of the chain gives up a pair of electrons that combine with 2 hydrogen ions and an atom of oxygen to form a water molecule. Oxygen is the final electron quote-unquote carrier. In the absence of oxygen, electrons cannot continue to pass through the electron transport chain and the aerobic reactions of cellular respiration. Thank you guys so much for watching. I hope you enjoyed, and I do apologize for not being able to read the whole thing, but thank you so much.